Hello and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for today's video is how to check if an ITX map is multi-threading. Feel free to reach out to me on popular social media channels at Paul Brett Tech. There are many settings that can stop a map from multi-threading, i.e. multiple copies of the same map running concurrently. In this demonstration, I show how to check if maps are in fact multi-threading, and some of the settings that can cause single threading, such as non-unique audit log, non-unique content rules trace, non-unique workspace file, non-unique file-based targets, and then of course the flow settings or the dtx.ini or config.yaml settings. I have a simple launcher running with one watch. That watch is being displayed on screen on the right with the IBM Launcher Monitor program. On the left I have a command prompt, and from this command prompt I can launch a map to inject a message into the queue. On the right you will observe maybe a small green dot that indicates one map has run. I have another map that can inject many messages into the queue, and I shall run that now. In the launcher monitor you can see that multiple maps are running to pick up those messages. Now, because the maps don't run for very long, it can be difficult to see whether these green lines are in fact overlapping. So one of the tricks that I want to use is to actually slow down map execution. I've written my map to read a file called Delay.txt, which is currently set to 0, if there is a value in there to pause for that many seconds during execution. I'm going to update that file to a value of 3 for now, and I'm going to run the single message injection again. As you can see, the green line stretches across the screen for a much longer period of time. What this means, of course, is that when we inject multiple messages, the green lines are clearly overlapping and we can clearly see that multi-threading is occurring. The rule that I used to achieve this slowing down trick will be part of the video description. Another way to check if maps are multi-threading is to review the audit logs. In the audit logs you have a start time and you have a map execution time. A review of 2 concurrently executed maps should easily be able to tell you whether they were running at the same time based on the start times and the execution time. I'm going to produce some audit logs momentarily and we shall have a look at that. So let's stop this system for a moment and go through some of the settings that will force single threading. Here is my system, and if I bring up the launcher settings and turn on map audit, the audit location is currently set to map, the file name is set to default, so this will in fact force single threading. I'm going to deploy those changes now. I'm going to restart the service, and then I'm going to trigger some messages to be injected. I've still got my 3-second delay. Only now you will see that the maps run one after the other. They can't multi-thread because they are all writing to the same audit log, and the resource manager is forcing them to single thread, wait until each one is executed. Let's not let that empty the queue out, let's just stop that there now. Back to the integration flow designer, I'm going to update the launcher settings again. And I'm going to change the map audit logs. I'm going to leave them on, but I'm going to change them to unique. Still in the map directory, but each one will have a unique name. This will reverse the previous change, and in theory we should see multi-threading again. Let's deploy those changes, start the service. The service will pick up from where it left off and hopefully pick up the rest of those messages. And there we go. A bunch of maps have kicked off all concurrently and are producing unique audit logs. Let's have a quick look at those unique audit logs. They've arrived here in my Explorer. I'm going to open the first one and dock that file on the left of my screen, and then I'm going to open the second one and dock that on the right. Okay, so we know that both maps started at 17, 38 and 50 seconds. Both maps ran for about 2.6 seconds. So with this proof, we know that this system is multi-threading. When the execution times become a lot smaller, it can become a lot harder, and with milliseconds not shown in the start time, it can also become hard. A recent enhancement available in the new ITX 11.02 version means that the start time now also shows milliseconds. So it will become a lot easier to see if maps are multi-threading using just the audit logs. So let's close those two for now, and we'll stop the system again, and I'll undo that change that I did. I don't want the audit logs being produced. So I'll just switch that back to off for now. And let's have a look at map trace. Currently this is set to off. Trace location is set to map and default. Now if I switch that to on and leave map default, I'm also going to need to turn on input content tracing so that something gets produced. With this set of settings, single threading will occur again. Not because of the audit log, that's been turned off, but because of the trace. Other settings that can cause single threading. Workspace is currently memory. If I was to switch that to file, the directory where the files will be produced is map, and the work file prefix is map name. So this is a fixed name again, so this will force single threading. If I was to switch to unique, this would allow multi-threading. Other settings. If we go down to outputs, currently set to write to MQ. If we were to use the file adapter and we were to write to a fixed file name, this again would force single threading. Multiple maps cannot be writing to the same file at the same time. The resource manager would detect it and force single threading. What else have we got here? Max concurrent map instances, currently set to 0, which means infinite. If we were to set this to 1 though, this would also force single threading. Other factors outside of the map and the flow can include things like the max thread setting in the dtx.ini file. Here we've got max thread set to 20, which is the default when the product is delivered. If this was set down to 1, then this would also force single threading. We've also got a setting called watch max threads. Currently set for 0, which is infinite, but if this is set to 1, then this also could force single threading. So in summary, I've showed how we can use the Launcher Monitor program to see whether maps are multi-threading by looking for the overlapping green lines. This can be further enhanced by slowing down map execution with a simple trick to introduce a sleep into the map execution. Additionally, the audit logs can be used. By comparing the start times of several audit logs and the execution times, you can see whether the times overlap by doing a simple bit of time math. This also can be made easier by making the maps run for a little bit longer. Settings that can force single threading include the audit log, the trace log, workspace settings, whether you have a file target, the max concurrent maps setting in the flow, and also the max threads and watch max thread settings in either the dtx.ini or the config.yaml file in ITX 11 onwards. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button. Perhaps leave me a comment. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Thank you.